So systems of inequalities. This is when we're actually going to graph multiple lines on the same graph and figure out what they share. Inequalities have the less than, greater than lines, just like we had with the absolute values. So that means we're doing what to the graph? What did we have to do whenever we had an inequality on the absolute values? Yeah, shade, because it gave us several solutions. Anything in that shaded region was a solution. We're going to start off with just trying to figure out the first question y'all will have on your homework. It says, what are the whole number solutions to this solution to this system of equations? And so we're actually not going to graph it. Whole number, let's start off there. What is a whole number? A number without a decimal or fraction. What else does it not include? Negatives. So I start at 0, go up towards infinity, but we can never touch infinity because infinity is not a whole number. Does that make sense? Yes. So do you think we're going to have to write an infinite number here? No. We're going to be restricted. So it says x plus y has to be less than 6. So x and y both can have zeros in them. So 0 is the first possible x. And what we're doing, we're just going to make a table of values. We're going to list the x in the first column, and then in the next columns, we're going to list all the possible y's. Does that make sense? And so 0 is the first one. 1, 2, 3, 4, 5, 6, 7. I went ahead and listed several here, but are we going to be able to use all those x values? No. What number is this largest x value I can go up to?
6.
Well, is 6 plus something less than 6? So it'd be 5. So 5 is our farthest number we can go. So anything below that isn't needed.
So we're going to have a 6 plus 0?
6 plus 0 is not less than 6. So we're looking for 5's the biggest number sum-wise we can end up with, correct? So now we're going to try to figure out what numbers I can add into my x. And we're going to do it all the way across. We're going to start with 0, and we're going to figure out the numbers. And we're basically sticking with this first rule first. Does that make sense? So take one rule at a time. So x is 0, so 0 plus what is going to be less than 6? 5 is the biggest one, right? But I can list everything up to 5. Okay, so 1. 1 plus what numbers? 0 through 4. 2 through what numbers? So you see how I don't have to really do a whole lot of math. It's still a pattern that I'm processing. So 3 plus what numbers?
0, 1, 2.
4 plus what numbers?
0, 1.
And 5 plus what numbers?
0.
Okay, now we're going to take the second rule. And I'm going to use a highlighter to help us find one that works for it. We're going to highlight it. I'm going to use a yellow highlighter to say the ones that are solutions to this. So our rule is 2x has to be less than y plus 3. So 2x, and I'm going to show my work down here. So 2 times 0. So that's 0. Has to be less than y plus 3. So, in that case, is 0 going to be less than whatever I put over here? So these all would be possible solutions. Does that make sense? We're in the process of eliminating out. So if I put in a 0 for y, would it work? Is 2 times 0, so 0, less than 0 plus 3, 3. And so I could go through and try each one of these and see which ones of them work. So we're going to do the same thing with a 1 for x. We're just going down to the next row. So that's going to be 2. 2 has to be less than whatever we come up with. So is 0 plus 3 greater than 2?
No. Yeah. Oh, wait.
So would then everything else be bigger than that? If I had 1 plus 3, that's a bigger number, right?
Yes.
How about, and we're just going to keep going down the list until we can find ones we can eliminate out. And it may not have any other ones. And then that may just be the whole list that we'll highlight. So 2. So 2 times 2 is 4. So 4 is a number we need to be bigger than. So 0 plus 3. That's not bigger than 4. Okay. 1 plus 3. Two plus 3. So 2 and 3 on this row would work. Because they're going to be bigger. Each time I'm stepping up, I'm getting bigger. And so we're going to do when x is 3. So that's going to be 6 I'm looking at being greater than. And so this is y plus 3. And so 0 plus 3, is that going to be greater than 6? Is 1 plus 3 going to be greater than 6? How about 2 plus 3? Oh, I forgot to highlight. There. Okay, we're going to go on to do 4. 4 times 2 is 8. Is 0 plus 3 going to be greater than 8?
No.
Is 1 plus 3 going to be greater than 8?
No.
How about, do you think, on the 5? Think that one's going to work?
No.
Because we have to be greater than 10. And so you'll find that there's going to be a pattern. So what does this mean? That means that, and I'm just going to take a couple of the points and I'm not going to keep on going on this. That means the ordered pair of 0, 0 is a solution. The ordered pair of 0, 1 is a solution. And each of those ordered pairs are solutions. So I take a number in each row, out the x, and it matches with y's, and that makes our order pairs. And they're each. And so 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and so forth. Those are each solutions. So the solutions are anything that makes both rules true. Does that make sense? Okay. Typically, we're going to do this with graphing. So here's example 2. And we're going to graph 3 different graphs. And we have two equations or two inequalities with each graph. I'm going to use different colors so that when I graph it, you can see the different colors. And so x is greater than 1. So that's this constant graph that's a vertical line. Is it going to be a solid vertical line or a dashed vertical line?
Yeah.
Why is it dashed?
The equal to line and
If I was to shade this, which way would I shade? Which way is x greater than 1?
yeah.
I'm just drawing arrows from my graph. Do not shade, just draw arrows right now. Okay, we're going to do this. Now we need to graph this other one. Is this other one a vertical or horizontal line, or is it a slant line? And how do you know?
Would it be slant?
It'll be slant because there's y.
Because there's y and x in it.
Because there's y and an x in it. So we need to have our y-intercept. So where does it cross the y-axis?
At the 1.
1.
At the 1. 0, 1. And I need to move with my slope. There's not a number in front of x, so what number is understood to be there?
1, 1.
So that means I rise up 1 over 1 each time. Is it going to be a solid or dashed line?
Dash.
So drawing a dashed line, going through 1, 1, or 0, 1, with a slope of 1 over 1. And it says y is less than x plus 1. Says I can shade above the line or below the line. Below. So solutions are where both lines shade. I'm going to number these spots so we can discuss it. You don't have to number your graph, but it breaks up the graph into 4 sectors. Which of those sectors is shaded by both? So we're shading to the right of the purple line and below the blue line.
3.
So 3 is a one that has both to the right of the blue line and below the, or to the right of the purple line and below the blue line. So you'll shade this entire sector. So a solution to this would be any point in this green that we can come up with. Can a solution show up on the line? Because it is dashed, no. So anything in that shaded region, any order pair I picked, would be a solution. Okay? Let's do two, we're going to do 2 more graphs of these. And so on this first one, the one in black, what is my slope? Or let's start off with the y-intercept first, sorry.
1.
0, -1.
So 0, -1. And my slope would be the -1/3. So that means that I have a negative slope, that means I either go down and to the right or up and to the left. So down 1 over 3. Down 1 over 3. And is this going to be a solid or a dashed line? Dash because it doesn't have the bar underneath it. Am I going to shade above or below when it's less than? Less than, below. Now for my blue line. My y-intercept is what? Zero comma 1. My slope is it's a 3. So how do I need to write that so I can move with my slope? It's positive, so that means I rise up 3 over 1. Is this line going to be solid or dashed? Solid because it has an equal to. Y is greater than, is that above or below the line? It's above. And so if you have troubles determining if it's above or below, choose the y-intercept. Which way would be above? Is it going to the going to the upper left or the lower right? And so looking here, that's above, so it's going this way. So what region is going to be below the black line, but yet above the blue line? Let's see. Let's number them again. I forgot to number. 4.
Yeah.
So anything in that shaded region is a solution, plus on this blue line, but not on the black line. One of the questions I think tonight is going to ask you, is this a solution, or which graph has this as a solution? So unfortunately, not every single one of them is going to be solved for y. Some of them we have to solve for y. So what's the step that you need to do first on number 4? Solve for y. So what needs to move away from the side with y? The 2x. So I need to subtract 2x from both sides. I know my sides because there's that inequality symbol, so I know I'm trying to keep on both sides of that inequality symbol. And so that gives me y is less than. Why is it plus 3?
Because it was a positive.
Because the 3 is positive. So my y-intercept, my slope, so that means I fall 2, go right 1 each time, or rise 2, go left 1. Is the line going to be solid or dashed? It's going to be dashed. And am I going to shade above or below this black line? Below, because it's less than. So on this blue line, I need to do what first to get it solved for y? And so we have a negative y is less than negative 3x plus 2, because that is a positive 2. Is this solved for y yet?
No.
We can't have a negative. So because this is negative, we need to actually change every single one of these signs. So it's going to be y is greater than positive 3x minus 2. So my y-intercept,
0, -2.
my slope,
3/1.
and it's positive, so that means I'm rising and going to the right, or falling and going to the left. Is this line going to be solid or dashed? So because of the non-equal to right here. That's the reason it's dashed. And are we going to shade above or below that line?
Above.
Look back at to the after we change the inequality symbol. This is where people make mistakes whenever you get to solve for y and the y ends up being negative. And so we're going to shade above. So does that mean we're going to shade in 1, 2, 3, or 4? 4, because 4 is below the black, but yet above the blue. So does a quadrant stop me on shading, or does it go past the x-axis or y-axis? So does this line here, the x-axis, matter
No.
when I'm shading my regions? No.